Hi, welcome to Learning Monkey. I am Raghu here. In this class, we'll discuss about range and quartile deviation. In our previous class, we clearly discussed about what's quartile points and what is measure of dispersion means. Please watch that classes and come back here. These are two ways to find the measure of dispersion. We'll go with examples and understand how we find the measure of dispersion. Coming to today's class, range and quartile deviation. We take some examples. Take our data is distributed like this, 8, 5, 16 and so on. This is our data is. First we have to arrange our data in ascending order, 5, 5, 7, 8 so on, and the final one is 37. If you want to find the range value, range is identified like this. Range is equal to 37 minus 5 means 37 is the maximum value we are having, 5 is the minimum value we are having. So maximum value minus minimum value, we will get it as 32. This is how we find the dispersion, measure of dispersion, but it is very simple way and it is not much used in our statistics. But there is a way to identify the measure of dispersion. This is one of the way. Range is one of our way. So measure of dispersion means how much the spread of the data is. That is what measure of dispersion means. Coming to our second technique, this is quartile deviation. In our last classes, we clearly discussed about what's quartile data point means. Q1, Q2 and Q3, 3 quartile points will be there. Q1 means lower quartile, Q3 means upper quartile. So if you want to identify the quartile deviation, this is the equation. Quartile deviation is equal to Q3 minus Q1 by 2. So this is the value of measure of dispersion of the quartile based on quartile deviation. We take an example and understand then what's the uses of this when we are going to use this quartile deviation. Example 8, 2, 5, 1, 9, 15, 27, 3, 25, 27. Arrange them in ascending order. If you arrange them in ascending order, these are the values which we get. From this we have to identify the quartile points. Q1 is identified. N is equal to, here it's not 1, 11 data points are there. So yeah, Q1 is equal to n plus 1 by 4th observation, we call it as a Q1, and 3 multiplied by n plus 1 by 4 observation, we call it as Q3 quartile point. So Q1 quartile point is this. This is our Q1 quartile point, 20 is our Q3 quartile point. If you want to identify the quartile deviation, Q3 minus Q1 by 2, that is 20 minus 3 by 2, that is equal to 8.5. This is what our quartile deviation says. So when we are going to use this quartile deviation, this is useful when we need the dispersion of middle 50% observations. So how our middle 50% observations are deviated, how they are dispersed. When we need that, this quartile deviation is very helpful. See here, why we are calling it as middle 50%. In our previous classes when we discussed about quartile points, we clearly discussed this. 25% of the points on the left hand side of the Q1, 25% are there on the Q3 point. In middle we are going to have 50% of our data points. How these 50% data points are dispersed, this is what our quartile deviation is giving us. So now coming to the next point, not involving the extreme terms. The first 25% data points are not involved in our quartile deviation, and the last 25% data points are also not involved in our quartile deviation. So our quartile deviation is not getting affected because of outliers. This is the point you have to understand. Now coming to the next important point, sometimes we use quartiles to identify outliers. So in our data, if you are having outlying data points, how to identify this outlying data points? This is helpful in many of the data analytic techniques. So before your data, if you got ready with your data for analysis, you have to eliminate the outlying points. How we identify the outlying points? This is one of the way to identify the outlying point. This is not the only way, this is one of the way. So how we identify that? We'll go with an example. So we will identify the interquartile range. How we identify that? Q3 minus Q1, we call it as interquartile range. So take this example, the same example, Q1 is equal to 3, Q3 is equal to 20. So interquartile range means Q3 minus Q1, that is equal to 20 minus 3, that is equal to 17. So based on this interquartile range value, we are going to identify. See here, whenever you are talking about outlying points may be on the minimum side. Outlying points may be on the maximum side. You can have outlying points anyway. first classes when we discussed about arithmetic mean, we clearly discussed about what's outlying point means. So let's refresh the point what's outlying point means. Suppose if you consider your data as all the employee salaries in your company, if you add all the employee salaries will be around 30,000, 40,000 like this. If you add the CEO salary to this, CEO salary will be an outlying points. It is around 200,000. So all of them are somewhere, and CEO salary is very far away from this remaining points. That points we call it as outlying points. So your outlying point may be on the minimum side or on the maximum side. How we identify the outlying points? Q1, if you want to identify the points, outlying points on the minimum side, Q1 minus 1.5 multiplied by IQR. So why we got this 1.5 value? As of now, remember, we are going to discuss this, what's the value of this one, why we got this 1.5 value when we discuss about in our coming classes, when we discuss about Gaussian distribution or normal distribution. There you are going to understand why they are using this 1.5 as a value. That is equal to 3 minus 1.5 multiplied by 7, that is equal to 20 minus 22.5. This we consider it as a outlying point. Below that, below minus 22.7 is considered as an outlying point. See here, we are identifying outlying point based on the interquartile range. What is interquartile range? It is the middle 50% values, we call it as a interquartile range. So based on that middle dispersion, means middle spread of data, middle 50% data value spread, we are going to identify the outlying points. So similarly, if you want to identify the outlying point on the maximum side, Q3 plus 1.5 multiplied by IQR, that is equal to 20 plus 1.5 multiplied by 17, that is equal to 45.5. Above 45.5 we consider it as outlying data point. Similarly, so one more concept also you have to understand based on this quartile deviation. Coefficient of quartile deviation, it is a relative measure of quartile deviation. Whatever we measured previously, quartile deviation, that is a absolute measure. This is a relative measure of quartile deviation. That's the equation is QD is equal to Q3 minus Q1 by Q3 plus Q2. So when we are going to use this relative measure of quartile deviation, use it to identify degree of variation in different distributions. If you are given two different distributions, so which one is having the highest degree of variation, that we are going to identify using this relative measure of quartile deviation. We call it as coefficient of quartile deviation. Relative measure, we call it as coefficient of quartile deviation. Let's take an example. See, this is one distribution, and if you identify the coefficient of quartile deviation, Q3 minus Q1 by Q3 plus Q1. So Q1 is 3, Q3 is equal to 20. So 20 minus 3 by 20 plus 3 is equal to 0.73. Similarly, if you take one more distribution, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. If you take the Q1 point, this is 3 value, Q3 value, this is 9 value, 9 minus 3 by 9 plus 3, that is equal to 6 by 12, that is equal to 0.5. This is how we use this relative, which one is having the highest measure of dispersion when compared to these two distributions, is this is having the more distribution. This is how we use the relative measure of quartile deviation, which we call it as coefficient of quartile deviation. These are the points you have to understand for quartile deviation. Hope you understand the concept. If you have any questions regarding the concept, please post your questions in the comment section below. Thanks for watching. If you haven't subscribed to our channel, please subscribe to our channel and press bell icon for the latest updates. Thank you.